For this example, notice how we have 4 divided by x squared plus 5x minus 14. And notice how in the note says partial fractions should only be executed whenever the leading degree of the numerator has exactly 1 less degree than the leading degree of the denominator. So in this case, what we have to do is, for step 1, and this is only the first step you do in a lot of cases, for step 1, the first thing we do is we drop the integral sign and we factor the denominator. So we drop the integral sign and factor denominator. So whenever we do that, we get, let's see, we get 4 divided by x squared plus 5x minus 14. And right now we're not worried about the integral sign because we're not going to use it anytime soon. So right now what we have to do is we just have to factor out the denominator. So here what we can do is find 2 terms, and this is just a quadratic, so we find 2 terms that multiply to be a and c and add to be negative and add to be b, which is the middle term. So we know that for negative 14 it could either be negative 7 plus 2 or negative 14 could be negative 2 plus 7. In this case we want it to add up to 5, so we pick this one right here. So now we can rewrite this as 4 divided by x minus 2, x plus 7. So that's step 1. So now for step 2, and the next step what we do is we're going to go ahead and, for step 2, we're going to decompose this into partial fraction form. Partial fraction form. And to do this, we just need to apply the quadratic, because since it's a quadratic, we're going to apply this method. And if you don't know how to decompose partial fractions, I have a video on that. So in this case, I'm just going to go ahead and do it. So here we have 4 divided by x minus 2 multiplied by x plus 7. And I forgot the parenthesis sign over here. But basically what we do is, since we have x to the power of 1, we just do a divided by, let me make that neater. We do a divided by x minus 2 plus b divided by x plus 7. Why did I do that? All I simply did was just split this up. This is called decomposing partial into partial fraction form. This is the key step to doing partial fraction integration. If you don't know how to do this in detail, I do have a video on how to do it when it's a quadratic versus when it's a repeating versus when it has a quadratic factor. So now that we have that, we can move on to step 3. So for step 3, all we simply do is just cancel out the denominator. So for step 3, we cancel out denominator. So basically right here we have 4 divided by x minus 2, x plus 7 is equal to a divided by x minus 2 plus b over x plus 7. And how do we cancel out the denominator? Well, to cancel out the denominator, we have to multiply everything by the denominator. So we have to multiply everything by the denominator. So we're going to multiply everything by x minus 2, and then we're going to multiply everything by x plus 7. And whenever we do this, we know that when we multiply x minus 2, it cancels out with the denominator. X plus 7 cancels out, so whenever we do that, we're left with 4 is equal to, when we multiply x minus 2, x plus 7 divided by x minus 2, the x minus 2 cancels, but we do have this term, so we have a x plus 7, and then we have plus b, and then the x plus 7 cancels, but the x minus 2 survives, so we're left with x minus 2. We're left with x minus 2. So now that we do that, for step 4, we're going to go ahead and just simply simplify. We're simply just going to simplify this. So when we do simplify this, all we're doing is literally just distributing. So 4 is equal to a, oh, sorry, we're distributing now, 7a plus bx minus 2b. So that's us distributing. So now that we have that in step 5, all we simply do for step 5 is just solve for a and b. And we do this by setting a system of equations. So notice how we have which I'll group these terms together. Notice how we have ax and bx, and then notice how we have 7a and negative 2b without the x term. So basically what we can do is we can rewrite this as, so we can rewrite this as 0x plus 4 is equal to ax plus bx plus 7a minus 2b. And why am I rearranging them? This is why I'm rearranging them. I'm rearranging them because this 0x is very important, and it comes into handy a lot whenever we're trying to solve for a and when we're trying to solve for b. So in this case, what we do is we group all the terms that are a of x, which are these 3, and then we group all the terms that are without the x, which would be these 3. So we rewrite this. Our system of equations is 0x is equal to ax plus bx, and then we can rewrite this as a plus b times x. And then we have our second system of linear equations. We have 4 is equal to 7a minus 2b. So now what we simply do is we simply just use algebra and we solve for a using the system of equations that we have. So notice how we have 0x is equal to a plus b x, and we know that x cancels out, so we know 0 is equal to a plus b, so we know a is equal to negative b. So we have this equality right here. But now how can we use this other equation that we have? So basically what we're going to do here for this case is we're going to substitute this a and get it in terms of negative b and solve for b. So what exactly am I doing? So right here we have 4 equals 7a, I'm going to put parentheses around a, minus 2b. And what I'm going to do is I'm going to substitute the a for negative b. Negative b minus 2b. Now that I have this, I'm going to go ahead and factor out b. So what is minus 7b minus 2b? It equals 4 equals negative 9b. And then we solve for b. We get b is equal to b is equal to 4 negative 4 over 9. So this is our b. And what's our a? Our a is the opposite sign. So a, because of this equation right here, our a is simply equal to plus 4 over 9. So these are the two equations that we have. So now, what do? We go back to our partial fraction form, which we're about to do right here. That partial fraction that we had earlier, and we came up with this right here. Four divided by x minus 2, x plus 7 is equal to a over x minus 2 plus b over x plus 7. So what we're going to go ahead and do now, so all we're going to simply do is just copy this and bring it down here. And now for step 6, our final step is we plug in a and b and integrate. So whenever we do this, we plug in a and b. So we treat this as an integral now. We treat this as the integral of 4 divided by x minus 2, x plus 7 is equal to a. What's a? A is plus 4 over 9 over x minus 2, integral sign, parentheses, plus b. What is b? B is minus 4 over 9 divided by x plus 7. And all this is being multiplied by dx. So now what we simply do is, now that we plugged in, we simply just integrate this. And we can take this a step further and split up the integral, so we get the integral of 4 over 9, we get 1 over x minus 2. X minus 2 times dx minus 4 over 9, integral sign, 1 over x plus 7 times dx. So whenever we integrate this, we get 4 over 9, the natural log of x minus 2, minus 4 over 9, the natural log of x plus 7, and then everything's being added with c, and that's our final answer. So basically what we did here was we just followed these 6 steps, and if you follow these 6 steps, you'll be able to do any problem with respect to partial fraction integration. The key step also is understanding how partial fraction decomposition works. So in quick retrospect, I'm going to go back and do everything in 30 seconds. So the first thing we did was we noted that partial fractions should only be executed whenever the leading degree of the numerator has exactly 1 degree less than the leading degree of the denominator. So we did that. We factored in the denominator, and then from there, after we factored it, we decomposed it, applying the partial into partial fraction form. And in doing this, if you know how to do this, I have a video on how to do partial fraction decomposition. But basically, it's just a over x minus, I'll call it c. And then the next thing we did was to cancel out the denominator. And then from there, we took it a step further. We simplified. We solved. We used 2 linear systems to solve for a and b, and we got that. This is honestly the most hard part. This is the part where you have to do the most problem solving, because we have 2 linear systems. We have, and I'll go ahead and draw a rectangle around them. So we have this one right here, and then we have this one right here. So you need to use those 2 to solve for a and b. Once we solve for a and b, we plug a and b back into the formula, and then we integrated. And then we ended up getting a final answer of 4/9 natural log of x minus 2 minus 4/9 natural log of x plus 7 plus c. Thank you for watching. I hope that was helpful. This integral right here, 2 plus x squared divided by x cubed plus 9x. So the first thing we're going to do is we're going to factor the denominator out and temporarily drop the integral sign because we don't need it right now. Because the first part of partial fraction is partial fraction decomposition. And if you're not familiar with it, I have a video where I explicitly go over how to do partial fraction decomposition, and which is these right here. So we do have to familiarize ourselves with this table when it comes to doing partial fraction. So quick note, the leading degree of the numerator must be exactly 1 degree less than the leading degree of the denominator in order to apply partial fraction decomposition. So in this case, this holds true because the leading degree of the numerator is x squared and the denominator it's x cubed. So without further ado, we're going to factor the denominator as much as we can. So 2 plus x squared, x cubed plus 9x, and what we can do to factor the denominator is we can pull out an x, and we'd be left with x squared plus 9. So now that we factored it, for step 2, we're going to apply the partial fraction decomposition for a quadratic factor. So notice how we have x and then we have x squared plus 9. And notice that x squared plus 9 is considered a quadratic factor. So right here where my mouse is, we would apply this second row in terms of decomposition. And the x is just its own thing. So we would execute this by having 2 plus x squared divided by x squared plus 9 is equal to a over x, because like I said, x is just its own thing. It's not a quadratic. It's x technically follows the formula of ax plus b, so that's why it only gets just the a. However, the quadratic factor x squared plus 9 would be bx plus c divided by x squared plus 9. And that's just partial fraction decomposition. Again, if you're not familiar with it, I do have a video on it in this playlist. We applied partial fraction decomposition. We broke it down into a over x plus bx plus c divided by x squared plus 9. So again, the first term was just mx plus b form. The second term was a quadratic. So that's why I decomposed it like that. So now what we're going to do in step 3 is we're going to cancel out the denominator, so we can just have one line of equation. So 2 plus x squared plus 9, we're left with a over x plus bx plus c over x squared plus 9. And what we're going to do is we're going to try to get rid of the denominator, so we're going to multiply by x and then x squared plus 9. So what we're going to do is we can cancel the denominator on the left-hand side of the equation. We can cancel out the x and the x squared plus 9, respectively, with each term. And what we're left with is 2 plus x squared is equal to a over the x's get canceled, so we're left with x squared plus 9. And then the x squared plus 9 gets canceled, so we're left with bx plus c times x. So that's our one line of equation. So in step 4, we're just going to simplify this. So 2 plus x squared is equal to a x squared plus 9a plus bx squared plus cx. So now that we have a one line of equation, what we're going to do now is we're going to actually try to solve for a and b. So now we're going to actually solve for a, b, and c. So here's our linear equation, which is x squared plus 0x plus 2 plus ax squared plus bx squared. I'm going to put these in descending order, plus cx plus 9a. And one thing I do want you to notice right here where my mouse is I added in a 0x. Why did I do that? Well, because the 0x is always there, it's just not implied. Because we had originally x squared plus 2. It's also implied that there's a 0x right there, which will help us solve later on. So what I want to try to do is set up equations that will help us solve this system of equations. So right here, x squared, because that's a 1, x squared has a coefficient of 1 in front of it. What we're going to do is set this x squared is equal to every other term that has x squared on it. So ax squared plus bx squared. So furthermore, what we can do is 1x squared is equal to a plus b x squared. And when we have it set up like this, the x squares will cancel each other out. So in essence, equation 1 that we have is 1 is equal to a plus b. So the idea here is just setting up equalities that we can later substitute. So I'm going to split up the board like this, and now 0x is equal to what term has x in it? Just x, not x squared, would be cx. So 0x is equal to cx, and that's the only term with x. So in essence, the x's will cancel out. So we know that c is equal to 0. So that's why this method works. Just set up whichever ones have the same degree with each other, set them equal to each other, left hand and right hand side. So now we have a 2 right here, and we're left with 9a. So these have a degree of 0, so they don't have an x term on them. So we know that positive 2 is equal to 9a. So we know that 2 over 9 is equal to a. So now we have a solved for. So now we can use this equality right here to solve for b, because now we have a. So recall b is equal to 1 minus a from this equation right here in the green brackets. So now we're going to substitute in a, 1 minus 2 over 9, and I'm going to choose to change the 1 into a fraction of 9 over 9, so we have a common denominator. So 9 over 9 minus 2 over 9, of course, is equal to 7 over 9, positive 7 over 9. So our b is positive 7 over 9. So now that we have a, b, and c, what happens next? So now that we have a, b, and c, what we're going to do now is step 5 and step 6 is we're going to plug in a, b, and c into the integral and integrate. So keep in mind that when we decompose this applying partial fractions, we had already set up a, b, and c. So now we're simply just going to plug those back in. So we know that ax plus a over x plus bx plus c over x squared plus 9 is equal to our a was 2 over 9 over x plus our bx plus c. Our b was plus 7 over 9 x plus c. Our c was simply 0 divided by x squared plus 9. So we're going to integrate this function with respect to x, and we know this term will zero itself out. So a quick note I want to make before we start integrating is that it simplifies and reduces your error if you break this up into separate integrals before you integrate. That way you do not mess up especially with partial fractions. It's very handy to do that. So that's what I'm going to do. So the first integral is 2 over 9, the integral of 1 over x times dx. And I'm going to put red brackets around that, and then plus the other integral is 7 over 9, and the integral of x over x squared plus 9 times dx, because keep in mind the 7 over 9 has an x with it, and it goes to 0. So what I'm going to do now is I'm going to integrate each one separately, then I'll add them together at the end. So the integral of 1 over x is the natural log of x multiplied by the constant of 2 over 9. And I'm going to keep that in red brackets. And notice how I have the absolute value. The natural log, anytime you take an integral that comes out to be natural log, you have to have the absolute value sign. And now x over x squared plus 9. Well, I'm going to apply u substitution because they have a difference of 1. So my u is going to be the higher exponent, which is x squared plus 9. My du, the derivative of this function with respect to x, is 2x times dx. And now I'm going to solve for dx, and dx is simply equal to du divided by 2x. So that now I'm going to substitute the u and the dx back into the formula, applying regular u substitution. So this is equal to, in terms of u, positive 7 over 9 x divided by u times du divided by 2x. And I know that those x's can cancel each other out. And what I'm left with is I'm left with plus 7 over 18, because I can factor out the 2 on the denominator, and 9 times 2 is 18, divided by, or the integral of du over u. So keep in mind, the integral, what's the integral of du over u? Well, if you look at over here, the integral of dx over x was the natural log of x. In essence, this is also being multiplied by 1, so it's basically the same thing. So the integral of this function is the natural log plus 7 over 18, the constant, and the natural log of u. So now what I'm going to do is I'm going to substitute in what was u. So 7 over 18, the natural log of x squared plus 9, an absolute value. So that's, now that we have both of our integrals, now we're going to combine them to get our final answer. So our final answer is plus 2 over 9 natural log of x plus 7 over 18 natural log of x squared over 9 plus c. Do not forget the plus c. And that's how we do this problem. But let's move on to the next problem. So in this example, I have 4x minus 11 divided by x cubed minus 9x squared. So the first thing I want to do is I want to make a note to myself that I have to make sure that the leading degree of the numerator must be exactly 1 degree less than the leading degree of the denominator in order to apply partial fraction decomposition. So in doing so, in order to apply this, what I have to do is, for step 1, is I'm going to have to factor the denominator and temporarily drop the integral sign. So I'm going to go ahead and do that. So 4x divided by 11 is x cubed minus 9x squared. Don't worry about the integral sign. So what I'm going to do is I'm going to factor the denominator out as much as I can. So 4x minus 11 divided by x cubed and x squared. I can factor out an x squared, so I'd be left with x squared, and I'd be left with x minus 9. So that's as factor as I can get it. So now for step 2, I'm going to apply partial fraction decomposition. And keep in mind this is a repeating quadratic factor. So what I'm going to do here is I'm going to follow this second one right here because it's repeating. So what I'm going to do, what I mean by that is, so right here, 4x minus 11 divided by x squared, x minus 9. So now when I apply the partial fraction decomposition, what I'm going to do is, notice how this term right here has a power of 2, is I'm going to include it twice. So just take a look. So this is equal to a over x, x to the 1 power. In essence, it's this second one right here, plus b over x to the 2nd power, plus c over x minus 9. And if you're not comfortable yet with how to apply partial fraction decomposition, I have a video that I solely focus on just the partial fraction decomposition aspect. Not even the integration, just solely the decomposition, because it's super important. You have to know how to do it to do these type of problems. So now let's move on to step 3. So now that we have that, so keep in mind this is what we decomposed it to: 4x over 11 minus a over x plus b over x squared plus c over x minus 9. So now what we're going to do is we're going to cancel out the denominator so we can simplify this to one line. So let's go ahead and do that. So 4x minus 11, x squared a over x plus b over x squared plus c over x minus 9. So now we're going to multiply both sides by the denominator on the left hand side so we can cancel it out and have one line. So we're going to multiply this by x squared, x minus 9. This is coming from the denominator on the left hand side over here where my mouse is. And now what we're going to do is we're going to simplify this by canceling out the denominator. So these cancel out: x squared, x minus 9, x squared, x minus 9. These cancel out. And what we're left with when we simplify this is 4x minus 11, the denominator cancels out, and the a over x, we're left with x times x minus 9, because the only thing that cancels out from the denominator is 1x. And for b, the x squares cancel out, so we're left with b is equal to b times x minus 9. And for c, the x minus 9 cancels out, so we're left with c times x squared. So now what we're going to do for step 4 is we're going to go ahead and simplify this. So just basically distribute everything out. So 4x minus 11 is equal to ax squared minus 9x plus bx minus 9 plus cx squared. And furthermore, let's distribute that a out. 4x minus 11 is equal to ax squared minus 9xa plus bx minus 9b plus cx squared. So now what we're going to do in step 5 is we're going to solve for a, b, and c. So we're going to do this by just creating a system of linear equations and just applying substitution. So we're going to start out with applying our system of equations. So we want to create system of equations and then just plug things back in. So we have 0x squared plus 4x minus 11. And note that I keep a 0x squared because there's an invisible 0 there. There's an invisible 0 in front of the x squared, even though it's just 4x minus 11. This was equal to what we came up with as ax squared plus cx squared, and I'm going to put this in descending order because it makes it easier. Minus 9xa plus bx minus 9b. So now what I'm doing is I'm going to start creating a system of linear equations. I'm going to start with the 0x squared. So what I can do is I can set it equal to the other terms that have the same degree. So 0x squared is equal to ax squared plus cx squared. Furthermore, 0x squared is equal to a plus c x squared. I can factor out an x squared. And from here I see that I can cancel out the x squared. So in essence, I'm left with 0 is equal to a plus c. So for equation 1, I can say that a is equal to negative c. So I'm going to store this equation as equation 1. So now let me create my second equation. So I know 4x is equal to every term that has just an x on it. So it's equal to 9a times x plus bx. And what I'm going to do is now I'm going to factor out the x. So x negative 9a plus b. And now I can see that the x's will cancel out, so I'm left with 4 is equal to b minus 9a. All I did was switch the order, perfectly valid. So that's equation 2 that I'm going to store. And now I know that negative 11 is equal to any term that does not have an x on it, minus 9b. So since I have this set up, I know that the negative signs will cancel each other out. So 11 over positive 9 is equal to b. So now we have a b. So having b, we can substitute b back into a, and we can actually solve for a. So let's plug b into equation 2. So 4 is equal to b minus 9a. So that was equation 2. So let's solve for a now. So 4 minus b over negative 9 is equal to a. And all I did right here was just do algebra to solve for a. Subtract b, then divide by negative 9. So this in turn is equal to a. So now what we're going to do is we're going to plug in the b. So 4 minus 11 over 9 divided by negative 9. This is equal to A, which is equal to 36 over 9. All I did was just make sure they have a common denominator, minus 11 over 9, and all this is divided by negative 9 over 1. It's the same thing as negative 9. I just want to have a common denominator, so now what I'm going to do is I'm going to simplify this. So I know 36 minus 11 is 25. So 25 over 9 is my numerator, and my denominator is negative 9 over 1, but when I reciprocate it to multiply, it's 1 over negative 9. So to simplify this, I have negative 25 over 81. So thus A is equal to negative 25 over 81. So now that we have A, we can solve for C by using equation 1. So we can plug A into equation 1 to solve for C. So recall that equation 1 was equal to A is equal to negative C. So C is equal to negative A in essence, which means C is equal to negative 25 over 81. Thus C is equal to positive 25 over 81. So now that we have A, B, and C, let's plug it back into our integral. So now for step 6, what I'm going to do is I'm going to plug in A, B, C into the integral, and I'm going to integrate the function. So recall what we had originally set up was in partial fraction decomposition form was A over X plus B over X squared plus C over X minus 9, integrating with respect to X. So recall our A was negative 25 over 81, our B was equal to 11 over 9, and our C was equal to positive 25 over 81. So that's what we saw for in the previous step. So now we're going to plug these into the integral. So negative 25 over 81 divided by x plus 11 over 9 divided by x squared plus 25 over 81 divided by x minus 9, our C, with respect to x. So what I'm going to do is it simplifies and reduces error if you break this up into separate integrals, so that's what I'm going to go ahead and do. So negative 25 over 81 in the integral of 1 over x times dx plus 11 over 9 in the integral of 1 over x squared dx plus 25 over 81, the constant, and then the integral of 1 over x minus 9 times dx. Notice how I matched the bracket colors with the respective terms. So this is with respect to A, with respect to B, and with respect to C. So now we're going to integrate each term, and all these integrals are none of them are very trivial, so we can just integrate them directly. So negative 25 over 81 and the natural log of x. Don't forget the absolute value sign when you're doing natural log. The second term is 11 over 9. And notice how this is not in form of 1 over x. So you would use the power rule. Do not make the common mistake of using the natural log. The integral of this is not the natural log of x squared. That's not how it works. From here, you would just use the power rule. So in doing so, 11 over 9, and the integral of that would be negative 1 over x. And then 25 over 81. And for this one, you would use the natural log because it's to the power of 1. So it would be the natural log of the absolute value of x minus 9 plus c. And that's the answer. Thank you for watching this video. I hope it was helpful. If it was, feel free to like and subscribe, comment, share. And I think the key to partial fraction is just knowing how to apply the partial fraction decomposition in the system of equations to solve for A, B, and C. And if you're not comfortable, there's a link down below to watch the partial fraction decomposition, or you can simply just find it on this playlist for Cal 2. Thank you for watching.